Welcome to Fixity Fix. Today we're going to be addressing a charging system problem, and we'll be doing a diode test using a digital voltmeter on the alternator itself while it's in the car and replacing the alternator. I'll take a break while you dance to our cheesy theme song.
Fixity Fix!
For months, the battery has been dying when the car's been left to sit for more than a couple of days. And we've been getting by leaving a charge pack in the car and just hooking it up to the battery and doing a quick jump start. Having gotten tired of that, I did a parasitic drain test by hooking up an amp meter between the battery and the negative cable and pulling each of the fuses. It's a finicky little technique, so look it up. There's lots of good videos on YouTube for it. I may do one at some point if I get the time. Ruled that out, ruled out a bad battery, even tested the alternator with one of those little connectors you hook up to the battery, said all that was fine, but the problem kept happening. So, digging down a little deeper, I decided to do a test of the alternator. I did remove the engine beauty cover. On the 2011 generation of the Mazda 3 anyway, the alternator is near the firewall on the passenger side on a US car, left-hand drive car. So the alternator is right here, this guy. And there is a heat shield near the terminal. You want to get at the positive terminal on the alternator, which is here behind this gray piece of plastic. So we have to remove these two 10mm bolts holding on the heat shield. Step one, pretty much as always, is come over to the driver's side of the car and remove your negative battery post. 10mm ratchet pops right off. Move it out of the way so it's not going to fall back onto the battery. I usually just tuck it into the tray. Your socket's going to get these two heat shield bolts off. Loosen them up. Trusty magnetic tray for sockets and screws and bolts and such. And then this guy, it's a little finicky, but you just wrangle it out of here. This is one of the reasons why you want to unhook that negative battery terminal so you don't short anything out. Set this heat shield aside. This plastic piece is covering up the positive terminal. If you reach under here with a screwdriver and push up on this little piece, or even better yet, get a small screwdriver into this little void right here and bend it upward and pull this plastic piece outward, it'll save you a trip under the car. I did jack up the car and got under it to get this off. Your mileage may vary. You might have good luck from the top. I think it's just faster since I have a quick jack to get under there. Pop this open and then you will see what they call the B+ terminal, the positive terminals. All right, get yourself a digital multimeter. Most of these things function a little differently, so you'll have to know your own pretty well. On this Tac Life, pretty cheap little meter, but works really well. It also has a DC amp clamp sensor, which comes in pretty handy on car diagnostics. Just doesn't go very low into millivolts to be reliable. For this test, for the diode test, you want to go into the resistance or ohms / diode mode. On this one, you're looking for this diode symbol here. It's next to the omega or horseshoe symbol. So you want to get out of ohms mode so that you get your diode mode in here. And this one reads 0.0. So we will first look and see, are we getting between 500 and 800 volts with black on the post and red on the case. I'm going to try to keep my arms out of your way for viewing the voltmeter, but I'll read it to you just in case. Don't have a camera person. Black to terminal, red to case. We have a reading. We have to let it stabilize a good little while here. Just under 500, 463 millivolts when it stabilizes. It's not quite within range. And now with red, reverse the connections. With red touched to the little post here, the B plus post on the alternator, and black to the case, we expect 0 millivolts. We initially got 0, but now we let it stabilize, and there it goes. It's coming up to 300 millivolts, 400 millivolts, 500 millivolts, oh, 600 millivolts. Okay, so we've got something wrong with the diodes, and this is more than likely the problem with our diode and rectifier pack. The alternator that is supposed to be charging the battery is draining the battery. There's your moment of zen for today, folks. One of those paradoxes in life. No amount of meditation or yoga is going to fix this. We're going to have to pull this alternator out of the Mazda 3 and put in a new one. The alternator in this generation Mazda 3 is driven by the serpentine belt, as is everything else in here. I think the previous generation has an AC belt. This would be an excellent time to change your serpentine belt, as long as you're removing it. I'm not going to change this one because I did it already a few months ago. The serpentine belt tensioner pulley is right below the alternator pulley. It will need to be turned clockwise using a tensioner pulley removal tool with a 14 millimeter socket on it. Let's go underneath the passenger wheel well for a better view. Easier to get at these tensioner pulleys, and these Mazda tensioner pulleys are a pain in the butt. By removing the passenger wheel and going in here, right above the CV joint there, you can see the language that says lift, and then there are 3 hash marks on the pulley tensioner surface there, and then right above the bolt there's an arrow, so your serpentine belt is tensioned properly if the arrow is within those 3 marks. You can use a standard pulley tool to loosen this pulley and get the belt off, but I recommend using a ratcheting tool, either from Lyle or from Gear Wrench, to go at it from the top. It makes it a lot faster. Turn the pulley clockwise, loosen the belt, slide it off of the alternator, and keep up with the orientation of the belt on all the pulleys, and you'll reverse that process once you get the new alternator in. We have a CarQuest remanufactured alternator that I got over at Advance Auto Parts. We want to bench test this alternator before we put it back in the car, make sure everything works. So we've got the digital voltmeter set to diode testing mode, the little triangle pointing to the bar. We want to see 0 millivolts when we connect red to the output post of the alternator and scratch on the casing of the alternator and hold that to let it stabilize. Good, the diodes are not pulling electricity from the battery. We want to make sure we're getting between 300 and 800 millivolts when we have black to the output post, the B plus post, and red on the case of the alternator. That looks good. 393 millivolts. I believe this part is going to solve our little problem. It's going to require a 12 millimeter wrench to get the battery cable nut off. There's something in the way of using a socket. All right, there's your positive battery cable. You reach under and pull off this low voltage piece. Pretty good view of the alternator guts from underneath. It really does pay to get down under here. We want to remove this bolt and this bolt down below. There's a similar 14 millimeter bolt. These are all 14 millimeters up top. You can see where the low voltage wire pops into here. You just pop it out. And this little nuisance right here needs to be pried out. Before I went under here, I got my 14mm socket loaded up and set it all ready to remove. And we're going to pop these 2 bolts. Loosen this one up a lot with your ratchet. And then it's probably just easier to pull them out by hand. Kind of regretting I didn't come under here with my electric socket wrench. The top one is still connected, and that's why I'm confident this alternator is not going to fall on my face. So these bolts come out. Keep up with them. We're going to clean them up really well because they are essential in getting the alternator grounded to the electrical system. Now we'll move back up top. And a 14mm socket says goodbye to this bolt. There we go. Knock it loose.
I said knock it loose.
There we go. Support the alternator. Ooh, that sucker is heavy. Okay, we're going to try to keep the serpentine cable semi-oriented here. I loosen this AC cable, or this AC hose. Hopefully I won't pop it and get a face full of Freon. Again, wear safety goggles. So here's the top attaching bolt, and then here are the bottom ones. Which one of these is not like the other? The top one does not have Loctite on it, so we're just going to clean it really well. The bottom 2 have Loctite. You can see the residue here, the white residue. We're going to clean that off and install more. And then we have to put on Loctite. I normally wouldn't be cleaning this over my engine, but I'm doing it to demonstrate the process. If you have a grinder in your shop that has a wire brush, that goes a little more quickly. I have one, but I don't feel like setting the camera up over there. Add a little Loctite in this convenient antiperspirant container, so the bolts will be nice and dainty if they meet a nut they really like. We always compare our old part against the new part, and you can see we have this shroud here that belongs on the new alternator, so I'm going to transfer that with 3 10mm bolts. Stand by. Correction, those are 8mm bolts. The second one I was taking out got trapped inside the socket, and I knocked it out with a screwdriver. It flew away. I've been looking for it for about 5 minutes. This is why I always say use the magnetic containers, which I am getting in a hurry, so I didn't. So I finally found it, looked all over the floor, walked around, felt something in my shoe eventually. It went into my clog. So don't wear clogs in the workshop either. In fact, you probably shouldn't wear clogs anyway. People will think you're old, but I am, so that's okay. I find it convenient and helpful to orient the 2 alternators the same way. The shroud pops right off of the old one. Make sure you maintain the rubber piece around the edge, and it moves right over, lining up exactly the same on the new alternator. Make sure the bolt holes line up and that the piece of the hunk of rubber comes along with you. And we start these bolts. These bolts have captive lock washers in them. We've tightened all these bolts down with a screwdriver, and this is ready to go back in the car. I don't know about you, but I love that part of a job like this when you start putting things back together. It just feels like progress. Let's see if we can slide this alternator under here. Don't really have a good angle for you here, but it's pretty intuitive where this thing belongs. The top bolt is the one without the Loctite on it. And tighten the bolt. You'll need to support the weight of the alternator while you screw this in to make it easier to bolt in. Easier to support by putting a hand under the alternator. I'm going to pull the serpentine belt roughly into place here, at least over the alternator, while it can still wiggle a little. While we can still wiggle it just a little bit. Now we'll head under the car, get the other bolts in, and get everything buttoned down under there. We're going to take a 14mm socket wrench with us. Above the car, we're going to make sure to set it to tighten. I'm going to take down this 14mm deep well socket too, just in case. Put it on my electric socket wrench set to kill. Back down below, we're going to put in some bolts. All right, there's one way this wire holder goes in. A good connection is critical, so you're going to want to brush down with a wire brush the connectors, which I'll do off camera just because it's hard to do with two hands, before we bolt on the main battery wire to the alternator's terminal. The nut just screws back on to the bolt. Finger tight, and again you'll need a wrench to get this just right. Push that in until you hear it click. Close this up so it protects the positive connector. Push back in this body panel clip. Keep that wire out of harm's way. You tighten these guys down here. Everything looks good from the bottom. So now it's back up to the top to tighten the top alternator bolt and to fight with the serpentine belt for 4 hours to get it on all of the pulleys. It just wasn't possible to show it with one person filming, but the serpentine belt is back on. You can see the 14mm socket here on the thin serpentine belt installation toolbar that I borrowed from Advance. You turn it clockwise and it moves this tensioner pulley over so that the belt comes loose. It's much easier to pull it off of this smooth pulley off and on, even though it's tight quarters, to get it back on. You do have to rotate it probably maybe 30, 40 degrees, 45 degrees to get the belt on and off without doing any damage to anything. So we'll put the heat shield back on and we should be able to test things out. Reattach this body clamp. There we go. Okay, that is the alternator all reconnected. Eyeballing the serpentine belt to make sure it's all on in the right places. So we've checked all of our connections. We want to go ahead and hook the battery back up. Let's make sure nothing blows up. Fire extinguisher is nearby, as always. Tight battery connection is a good thing. Sounds good. We check the running voltage of the car now. DC voltage. Red to red, black to black. 14.17. That is a lot better than the old alternator at 13.4. It really should be in the high 13s to 15.3 for a healthy alternator. This is right in the healthy zone. Now we go to voltage. And we select AC in the lowest range possible. This is an auto ranging meter, so it'll do it on its own. We want to see 0 or very close to 0 for AC. Alright, only 20 milliamps, that's pretty good. That's not going to be a problem. And we knew it wouldn't be because we tested the diodes on the bench before we put the alternator in. So this looks good. I think it's going to work out well. I'll update you in the comments later on.